Hey there, I'm Kevin, your friendly neighborhood chatbot. I'm here to engage in conversations, provide companionship, and bring some interesting topics to the table. So get ready to dive into thought-provoking discussions and have a blast getting to know me. Let's make this video fun and engaging together.
Hi, in this video I'll be talking about the development of Kevin, a companion robot that aims to provide conversation and a physical presence in dining settings. Loneliness is a prominent issue in the modern day, and the dining table is a place where it can be especially overwhelming. Eating alone shouldn't mean feeling lonely. That's why I made Kevin, the robot solution to all loneliness, especially my own. Well, they may be stretching it a little bit, but Kevin's capable of listening and speaking to the user, with a physical display to give it a face and make it more interactive. Now, how exactly does Kevin work? Let's talk about the parts first. Kevin's brain is a Raspberry Pi 4, a small but highly capable computer that runs Kevin's program and controls all of the other parts. Kevin's ears are a small USB microphone, which allows Kevin to listen to the user's speech. Kevin's mouth is a small Bluetooth speaker, which outputs the speech in the conversation it generates. Kevin's face is a 32x32 LED matrix, which has lights that turn on to make faces that lip sync to the speech as Kevin talks, making it a lot more fun to talk to. Finally, to contain all of Kevin's parts and act as a body, is a case that's 3D printed out of PLA. So, how do all these parts work together to make Kevin? All of Kevin's code was implemented using Python along with other libraries, APIs, and services. Kevin interacts with the user in the style of a back and forth conversation. Once the program is started, Kevin initiates the conversation by addressing the user in a greeting and asking a starter question. After doing so, it enters a stage of listening for a response using Pi audio and the microphone. If it picks up a sound louder than a certain threshold, it recognizes that the user is talking and starts recording their speech. Once the user goes silent for 2 seconds or more, Kevin recognizes that they've stopped talking and stops the recording, saving it as a temporary .wav file for further processing. Using OpenAI's Whisper, a pre-trained model for recognizing and transcribing speech, Kevin converts the audio file into a text transcript containing everything the user said. This transcript is then fed into ChatGPT using the OpenAI API with a relevant prompt and a response generated to continue the conversation. Once the text response has been generated, it must be converted to speech. Along with converting the text to speech, Kevin has to figure out how to lip sync to it and display the speaking face on the LED matrix. This was probably the hardest part of the project. I initially tried looking into generating phonemes, which are units of sound that describe what parts of a word sound like from the audio. To do so, I tried various forced aligners, including Gentle and MFA, and had a pretty frustrating couple of days with platform support and dependencies, trying to get them running on the Raspberry Pi. After a lot of troubleshooting and Googling, I did eventually find a solution that managed to address all the needs. AWS Poly. AWS Poly is an AWS text-to-speech service, solving one aspect of converting the response to speech, and it also has speech marks, which offer data about the speech Poly generates. And one of these types of data is visemes. Visemes are units that represent the position of the face when speaking a certain word. With AWS Poly, the visemes used throughout the speech file generated could be obtained along with timestamps at which each viseme is used. So, at this point, Kevin has a speech response as well as visemes to represent what his face should look like throughout the speech. From here, the viseme needs to be matched to faces that Kevin should display to make it lip sync to what it's trying to say. This video by Carrie KH is really useful in explaining how to do this. I made my lip syncing system a little simpler though. Using this chart from the video, I drew 6 basic faces to show the different mouth movements associated with each kind of sound. These faces were then matched up with each possible viseme that AWS Poly could generate. Using the speech generated by Poly, the viseme timestamps, and the mappings of faces to each viseme, Kevin speaks and lip syncs the response generated by the ChatGPT API with everything outputted on the Bluetooth speaker and LED matrix. Once Kevin is done speaking, it goes back to listening and the cycle continues. Now, that was a pretty long explanation. It might be easier to see how Kevin works in a real conversation. So, without further ado, here's a video of Kevin having a conversation with my friend Ryan.
Hey Ryan, how's your day going so far? Anything exciting happening?
Today, I got 100 on my chemistry test, and I'm super excited about that.
That's fantastic, Ryan. Getting a perfect score on your chemistry test is a great achievement. Congratulations. How did you prepare for it?
Thanks, Kevin. I studied really hard. I studied for probably 4 hours to prepare, but it paid off in the end, so I'm really happy.
That's some serious dedication, Ryan. It's great to see your hard work paying off. Keep up the awesome studying and keep acing those tests. I'm glad you're feeling happy and proud of yourself.
Thanks, Kevin. I'll see you tomorrow at breakfast.
Sounds good, Ryan. Looking forward to catching up with you over breakfast tomorrow. Have a wonderful evening and see you soon.
Thanks for watching. If you have any questions, feel free to let me know in the comments. Make sure to stay tuned because I have a lot of video ideas to get to posting in the next few months. Until next time, see ya.